15b number 8. Here are data on the percent change in the total mass in tons of wildlife in several West African game preserves in the years 1971 to 1999. So here's all your data. So this is the year, and the bottom of it is the percent change in total mass in tons of wildlife. So software gives the 95% confidence interval for the mean annual percent change as negative 6.66% to negative 2.55%. There are several reasons why we might not trust this interval. So let's go ahead and skip ahead to number 8. It says, which of the following questions does a test of significance answer? Actually, before we answer that, let's plot this. Just to remind you, in case you've forgotten, to plot all of this information, what you're gonna have to go and do is go to Stat, go to Edit, and your list 1 should contain your years. That's always the case. Your x-axis should always be the time, and your list 2 is the percent change in total mass. So all of this. So I plot all that down for us just to save us some time, and then I'm gonna go and go to Stat Plot right here. So yellow y equals, and you're gonna have to. This is usually in off like the rest of these. These are in off, but stick to the first one. Press enter there, and if it's in off, then you go to on and turn it on. And you're gonna select this because this is the scatter plot option, and then make sure that the X list is list 1 and the Y list is list 2. Then you press graph. Now what usually happens when you press graph is it'll show this picture. So if it's showing that, then you're gonna have to go and press zoom stat. You go to zoom and then go to zoom stat, and there it is. Okay, so that's this data right here in scatter plot form. Which of the following questions does a test of significance answer? Remember, when we're doing tests of significance, what we're doing is we're testing out what the chances, or we're trying to observe if this is just chance that we're getting all of this data, assuming that our population information is true, assuming that we have the information of percent change in total mass in tons of wildlife everywhere, assuming that that population information is true, what is the chance of getting this data? And so that's what it is. So of our options, it says, is the sample or experiment properly designed? That's not test of significance. B is the observed effect due to chance. That's what it is. And C is the observed effect important? And that's not what test of significance does. So we're trying to observe if this effect is due to chance, and we use the p-value to figure out what is this chance that we get this this information. And if getting this data is really unlikely, that means we have a small p-value, and then we compare that p-value to an alpha level. So if our chance is a really small p-value, that means that this effect is really unlikely to occur, right? If our p-value is really, really small. So for something so unlikely to occur, assuming if the p-value for this information is small, then we would compare that to an alpha level and then make judgments whether or not we reject or accept the null. So again, is the observed effect due to chance? I hope that's clear.